Hi, I'm the wannabe coder, and welcome back to the Pac-Man in Python series. This is episode 9, and it's the final episode of our journey building Pac-Man using Python and Turtle graphics. In this episode, we're going to add the final polish to our game, with custom graphics and sound effects. We'll start by replacing the default shapes with custom images for Pac-Man, the ghosts, and the maze walls, to give our game a more classic and recognizable look. Then, we'll add sound effects for key moments in the game, like when the game starts, when Pac-Man eats a pellet, and when he loses a life. These small touches go a long way in making your project feel like a real finished game. By the end of this episode, you'll have a complete and playable Pac-Man clone, with working mechanics, visuals, and audio, built entirely in Python using Turtle graphics. But before we jump into the final touches, let's take a quick look back at everything we've built so far. We started by setting up the game window and designing a grid-based maze. Then we added Pac-Man with smooth movement, wall collision handling, and support for turning at intersections. Next, we built the user interface to show the player's score and remaining lives, and added collectible pellets and power pellets that boost Pac-Man's speed. After that, we introduced enemy ghosts, with their own movement logic, wall detection, and collision handling. In episode 8, we gave those enemies a simple AI to chase Pac-Man when he gets too close, and we tied everything together with game over and victory conditions, safe respawning, and a short delay before gameplay begins. So with all the core mechanics complete, now it's time to make the game look and sound great. By the way, all the code and files, including the images and sound effects, are available for you in my GitHub repo. You'll find the link in the description below. Alright, let's talk about the custom shapes. Since our entire game grid is based on 30 by 30 pixel cells, our image files also need to stay within that size. Otherwise, they won't line up correctly with the maze. Another important note, Turtle Graphics only supports GIF files for custom shapes. So make sure all your images are saved as .gif files and placed in the same directory as your project files. We'll go step by step and load these images shortly. But first, here's what I've prepared. For Pac-Man, I've created 5 images. One is a full yellow circle, used when he's idle or not moving. The other 4 are facing directions: up, down, left, and right, with his mouth open in that direction. For the enemies, I've created 3 separate images, one for each ghost, a pink ghost, a green ghost, and a red ghost, and finally, I've made one image for the maze walls to give them a clean and retro look. With those ready, let's now load them into Turtle and set them up inside the game. To get started, open your main Python file, main.py, the one that runs the game, and go inside the main function where you set everything up. Right after you create the game screen, we'll register each image by adding it to the screen using a built-in method. This tells Turtle to load the image into memory, so we can later assign it to Pac-Man, the ghosts, and the maze walls. To do that, we write screen.register_shape, open parentheses, and inside quotes, we type the file name, for example, pac.gif. Then we close the parentheses, and in the same way, we register all the other shapes. Now that they're loaded, let's go and apply them. We'll start with the enemies, scroll down to where we create them, and first, we'll make a list of enemy shapes. This list will include the green, red, and pink enemy images. Then, when we create each enemy, we'll randomly choose a shape from that list and assign it. So each ghost gets a different look when the game starts. So here's how we apply the images to the enemies. First, we create a list that holds the file names of the enemy images. We write enemy_colors equals open brackets, then inside quotes, green_enemy.gif, comma, pink_enemy.gif, comma, and red_enemy.gif, then close the brackets. This gives us a list of enemy shape options to choose from. Next, we go down to where we create our enemies. Right after creating the enemy, we set its image by writing enemy.shape, open parentheses, random.choice, open parentheses, enemy_colors, and then we close both parentheses. This picks a random image from the list and assigns it to the ghost. So each time an enemy is created, it will automatically choose one of the 3 images at random, giving each ghost a unique appearance every time you play. Now that our enemies use image files, we can go back to the actors.py file and clean up the enemy class. There are 4 lines we no longer need: the ones that define the turtle's shape, shape size, pen color, and fill color. Since we're now using images, those visual settings are handled by the image itself, so we can safely delete those 4 lines from the class. Now, let's scroll up to the player class. We'll do the same cleanup here. We can remove the 4 lines that define the turtle's shape, shape size, pen color, and fill color. But this time, we'll keep 1 line, the one that sets the shape to our default image, self.shape, open parentheses, and inside quotes, pac.gif, then close parentheses. This will be the image Pac-Man uses when he's not moving, a full yellow circle. Now, let's apply the directional images for Pac-Man. We'll scroll down to the end of the player class and define a new method that changes his shape based on the direction he's moving. We'll call it change_shape_direction. So what does this method do? It checks which way Pac-Man is heading and switches his image to match that direction. We start with this line: if self.state is not equal to stop. This means if Pac-Man is currently moving, we want to update his shape based on his heading. Then we use a few if statements to check which way he's facing. If his heading is 0, that means he's going right, so we set his shape to right.gif. If the heading's 180, he's moving left, so we use left.gif. 90 means he's going up, so we show up.gif. And if the heading is 270, he's going down, so we use down.gif. But if Pac-Man isn't moving, we fall back to the default shape, pac.gif, the full yellow circle. This gives Pac-Man a more animated feel, with his mouth always facing the direction he's moving. Now we need to call this method so that Pac-Man updates his shape while moving. Since this is part of Pac-Man's basic movement, we'll call it right inside the move method. So let's scroll up to the move function in the player class. At the very top of that function, on the first line, we'll call our new method by writing self.change_shape_direction with empty parentheses. That's it. Now, every time Pac-Man moves, his image will change to match the direction he's going. The last image we need to apply is for the maze walls. So let's switch over to renderer.py and update the part where we create the wall blocks, so they use our custom wall image. Inside renderer.py, let's scroll down to the wall class, the one responsible for drawing the maze blocks. Just like we did for the player and enemy, we'll clean up a few lines we no longer need. Go ahead and delete the lines that set the shape size, the pen color, and the fill color. Then, look for the line that sets the shape. It should say self.shape with square inside the quotes. We'll replace that with our custom wall image, so change it to self.shape and inside quotes, write wall.gif. This will apply the new image to every wall in the maze, giving it a cleaner and more classic look. Now go ahead and run the game, and take a look. You'll see that Pac-Man now has a fully animated look. His mouth opens in the direction he's moving, and when he stops, he switches back to the classic full circle shape. Each enemy now has a random color, red, pink, or green, thanks to the image we assigned when creating them. And finally, the maze walls now use a custom image too, giving the whole game a much more polished and arcade-style feel. All of these small upgrades really bring the project to life. Alright, the visuals are looking great. Now, let's take it one step further and add some sound effects to bring even more life to the game. Let's go and handle the sounds. But first, there is one thing to consider. This is the first time in the project where your operating system actually matters. I'm using Linux, and on Linux, the easiest way to play a sound is by using the aplay command. To play a sound file, I type aplay, followed by the file name, like startup.wav, and then I add an ampersand at the end so it plays in the background. The full line looks like this: os.system, open parentheses, then in quotes, aplay start_up.wav and an ampersand, then close the parentheses. To use this in Python, we first need to import the OS module. This module lets us run system commands from inside our code. So we write import OS and then call os.system with the play command inside quotes. Now, what about Windows and Mac? If you're on Windows, you can use the winsound module. To play a sound file on Windows, you don't need to use the OS module. Instead, Python comes with a built-in module called winsound. To use it, we first write import winsound, all one word, no spaces. Then, to play a file like death.wav, we type winsound.playsound, open parentheses, then in quotes, death.wav, comma, winsound.snd_async, and close the parentheses. That tells Python to play the sound in the background, just like aplay on Linux, so your game doesn't freeze. Now, for Mac users, it's similar to Linux, but the command is different. Instead of aplay, we use afplay, short for audio file play. Just make sure to update the command to match your operating system, so the sound will play correctly when your game runs. Alright, we're now going to add the final 4 lines of code, and with that, our game will be complete. We'll do this in the main.py file. There are 3 different sound effects we're going to use. A short sound that plays on startup during the initial delay. A sound when Pac-Man eats a pellet. Same for when he eats a power pellet. And finally, a sound when Pac-Man loses a life. To keep things simple, we'll just call the os.system command each time one of these events happens, just like we explained earlier. All you need to do is add one line in each of those places, using the correct sound file name. So let's switch back to main.py. At the top of the file, we first import the OS module by writing import OS. Then scroll down to the game loop function. This is where we handle all the collision logic. First, when Pac-Man eats a pellet, right after the collision is detected, add this line, os.system, open parentheses, inside quotes, aplay, space, eat.wav, then add greater than, /dev, /null, space, 2, greater than, ampersand 1, space, and ampersand again, then close the parentheses. This part at the end is used to hide any terminal output and run the sound in the background. But this is only needed if you're using Linux. If you're on Windows or Mac, you don't need to include that part. Next, when Pac-Man eats a power pellet, we copy and paste the same line. Then, when Pac-Man loses a life, we copy the same line again and change the file name to death.wav. And finally, for the startup sound, scroll to the main function. Right after we create the enemies, and just before the delay and control bindings, we paste the same line again, this time using start_up.wav as the sound file. And that's it. With those 4 lines added, your game now has sound effects for startup, pellet collection, and losing a life. Let's run the game one final time and enjoy the full Pac-Man experience, complete with graphics, sound, and gameplay. We've now got full visuals, animation, sound effects, working collision logic, enemies, scoring, win conditions. Everything you'd expect from a complete arcade-style Pac-Man clone. And the best part is, we built this game in a way that makes it super easy to customize and tweak. Want to change the maze layout? Just open the mazes.py file and update the grid pattern there. As long as you keep the same number of rows and columns and follow the grid structure, the game will still work. Want more or fewer enemies? Or to adjust their speed or behavior? You can change all of that in the constants.py file, so feel free to experiment, make it your own, and most importantly, have fun with it. And that's it. You've just completed an entire Pac-Man clone, step by step, using nothing but Python and Turtle graphics. If you followed along through all the episodes, you should be really proud of yourself. You've gained hands-on experience in building a real game from scratch and learned about modular code, game loops, collision logic, and more. I hope this series helped you improve your Python skills and showed you that building cool projects doesn't have to be complicated. You just need to break it down, one step at a time. Thank you so much for watching and for coding along. If you enjoyed this series, be sure to like, subscribe, and leave a comment to let me know what you'd love to learn next. More tutorials and projects are on the way. So, stay tuned, and as always, I'm the wannabe coder, and I'll see you in the next one.